Now we can convert acre inches per day into gallons per minute. And if you look in the back of your irrigation text, there should be some multipliers to do that. And we see that an acre foot is equivalent to 12 acre inches. So I'm going to have to do some converting here. So I can take this value and I convert inches to feet, so 1 foot, 325,850 gallons in 1 acre foot, 325,850. So far, we've managed to now convert inches out, and now we have acre feet per day. And now I've taken acre feet, the acres here and the feet here have canceled out. Now I have gallons per day. Okay, there we go. That's how many gallons a day we have to deal with. But now we're going to irrigate that over an 8-hour period, right? So we got to figure out our gallons per minute that we're going to need from our pump. So we're going to water this much in 8 hours. This is how many gallons per day we need, but we have an 8-hour window. So we know that we're going to put on 8,814,625 gallons per day, but we're going to do that in over 8 hours per day.
Eight hours is a third of the day. 8 hours.
Now, that will give us gallons per hour. And so we have to do one more thing. We have to get hours into minutes, and we know that there's 60 minutes for every 1 hour. And now we're in a position to get the values that we're after. Let's see if this works out. We have gallons, that stays the same. Days cancel here, hours cancel here, so we're left with gallons over minutes. So our answer is going to be in gallons per minute. Hip hip hooray, we might get a right answer here. So we'll divide by 8 and divide by 60, and that gives us a nice number of 1,697 gallons per minute. Now that is a pretty fair amount of pump station. Now what if we were able to water that over a 24-hour period? This number becomes 24. That would divide that number by 3. And so if we were if we did that for 24 hours, you know, if this number here were 24, this number then, we just divide by 3, this would be 566. For 24-hour watering. Now what happens to our pump station in that case? It only has to be a third as big. So whenever we tighten up this water window, what we're doing is we're costing ourselves a bigger pump station and also bigger main line to handle the flows that are going out into the field. So whenever we can, we try to get the maximum water window to get capacity. Now there is one nice thing about watering at night, which you do in turf. We get greater efficiencies when we water at night. So we do gain that way. We might gain a few percentages on the overall efficiency. Still, in the 24-hour period, we're still doing part of that watering at night, so it's at its highest efficiency. But during the heat of the day, we're at our worst efficiencies, and so we are not going to be quite as good a water users when we go 24-hour watering. But as far as the overall economics for agriculture, if you're out farming, it becomes almost a criteria that you go to a 24-hour cycle. Now that is less of an issue when you get into drip systems and micro systems that are under canopy of crops, and you don't have near the losses there either.